Hello, hello. Can you hear me, Ben?
Yes, hear you loud and clear. Can you hear me?
Yeah, I can hear you loud and clear. Amazing. Yeah, we're going to start now a workshop in a couple of minutes. It's presented by Ben, also known as Technoir, on how Istarai, an agent that was built based on Eliza, played Eternum. So Eternum, which is a fully on-chain game that is built on Starknet. And in this workshop, Ben is going to go over how he built Istarai using Eliza, and then eventually also in other frameworks such as Daydreams, which will come into the future, and how also the agent interacts with the game state of Eternum, and also what this means for other games that are fully on chain to be working in the agentic space. So yeah, Ben, why don't you introduce yourself, and then we can go and start the workshop.
Yeah, sure. Thank you for having me on the stream. Um, yeah, my name's Ben. I go by the pseudonym Technoir on Twitter as well. I am the technical associate at Bitcraft Ventures, who are a gaming-focused VC. We do traditional gaming as well as crypto gaming, which I'm solely on the crypto side of things. My job there is to basically help with technical due diligence, spend time in the trenches with devs, try to build stuff, learn how stuff works, and yeah, basically get a good understanding of what's happening on the bleeding edge of the intersection with crypto and games. So yeah, bit of a dream job, if I may say so myself. And yeah, the goal with this was to understand how the Eliza framework works. Um, I also spent some time messing around with the virtuals framework, ended up going to Eliza, and as you mentioned, I'm currently experimenting with Daydreams as well. But yeah, this kind of proof of concept, which I'm going to walk through today, the bulk of the code was written by Love, who was this is kind of like a proof of concept for what is now Dreams, so Daydreams. So I'll touch on that as well as we go through this. This is the first hackathon workshop I've ever done, so feel free to stop me if something's not clear. I'll try and go through it in a logical fashion and explain things with a sufficient level of technicalness. But yeah, if something's unclear, feel free to stop me, and also happy to take questions.
Amazing.
So, um, so I think the first thing that might be useful, and I know a lot of people in this hackathon have already been using Eliza to try and build various things, but for those that are not as familiar with it, it might be helpful to just give like a real high level overview of the architecture and how the different components hang together, which we'll be going into today. So this is not the best diagram, but I think it's a good way to just visually show what's going on. So at the core of the Eliza framework is the agent runtime, which is a class that's responsible for managing the agent's core functionality. That includes receiving messages from various clients, whether that be Telegram, Twitter, Discord. It's responsible for managing the agent's memory. So that includes like an initial memory store and being able to update the memory, taking into account ongoing interaction, so the agent can get context around a conversation that's happening or a chain of thought process, and maintain that throughout the entire operation that it does. And yeah, the agent runtime is responsible for executing any actions that you've registered with it, which we will go into in a little bit. The other thing to kind of talk about, which is not shown on this diagram, but it's kind of contained within these plugins, is providers and actions. So in Eliza, a provider, and this is a kind of a generic term in software engineering, but a provider is just a way to get access to some external system, that, like an API endpoint, for example. So this providers allow you to bridge between the agent and external systems. Actions define how the agent can respond and interact with messages, and the agent kind of decides itself based on the LLM response, which is the most appropriate action to take at any one time, given its current context. And all of this there are other things, but I would say for this example, at least, like providers and actions are the main things. And all of this is encapsulated in a plugin, which just makes it really easy to kind of install a like a self-contained module into the runtime. So let me get that out of the way. So I think what you're seeing on screen right now is the action is the plugin that Love created. It's the Eternum plugin, and this is what's really enabling Istarai, or the White Wizard as he used to be called, to play, a move in Eternum. So
Could you zoom in just a little bit?
Yeah, sure. Not too much. Is that any better?
Just a little bit more, but then should work. Yeah,
How's that?
amazing.
Okay, cool. So yeah, all plugins follow the same kind of type interface. So you have to give them a name, a description, and then you can register actions with them, or evaluators or providers in these arrays. So you can see that there's only one action registered here, which is generate, which is the generative action, which I'll be going into later. So I think the next thing to probably look at is how does the agent runtime actually get access to these plugins and actions. So there's basically two places you can do this. You can either include it in the character file, which would be an array in here. Let me go to there's an example one here that just comes with the main branch of the repo. You can define them here, or what we've done in this proof of concept is to just hard code them in the agent runtime. It would probably be better to do it in the character file, so that you're not having to hard code anything in the agent in the actual core framework. But we're registering the Eternum plugin here. There are some other ones registered as well. I don't believe this one's actually used for this POC because everything is actually in here that we need. There's a Bootstrap plugin as well, which is created by one of the other contributors in the space, and it just contains some basic kind of functionality that the agent might need. All of this stuff is not really used for the POC. The main thing is this. And I will go into the action in more detail shortly, but the other thing to point out in this file is the model provider. So this is pulled from the character file. So if we just go to the character file again, you can see that you can list which model you'd like the agent to use. Here we're using Anthropic. As you'll notice, this is a provider. Like we discussed earlier, this gives the agent access to the Anthropic API endpoint, basically. And then one other thing to cover on the models is this is not a specific endpoint that it's giving you. It's giving you access to all of Anthropic's endpoints, basically. So there is a file here which is part of the Eliza core package called models.ts. And in here, you can change the settings for the model. You can see here for the Anthropic one, we can change like the max input tokens that are allowed, max output tokens, the temperature, which kind of is a gauge of, I guess, the LLM's deterministic versus non-deterministic responses. Like a higher temperature will allow the agent to be more creative. You don't necessarily want that in this situation because you want it to be able to give you back. We're going to be using it to query GraphQL endpoints and create Starknet transactions. So you kind of want this temperature to be fairly low. 0.3 was a figure that it was through some trial and error, we found that was like the best number to use here. And then depending on what the agent is wanting to do, for quick like simple tasks, the framework will call the small instance of the model, and you can change this to whatever you want. Here I'm just using Haiku, and then there's medium and large, which we're using Sonnet for, which is capable of doing much more intensive queries. So yeah, I guess any questions before I move on? I'm going to look at the actual project structure now, and then we'll dive into the action itself and how that works.
Yeah, maybe a quick question I had. So, you can modify the temperature. For which type of game would you actually see a higher temperature, such as 06 or maybe even 07?
So I would say for this, if you wanting for the purposes of playing an on-chain game where you need to be able to query, retrieve data, do something with that data, you kind of want it to behave in a predictable way. Even though it has its own agency, it can choose to do things depending on the game state. You don't want it to be really creative with its output. You want it to just give you the data. I think if you increase it too high, you are at risk of hallucinations, which kind of breaks the whole chain. You would probably use a higher temperature if you're wanting to do more creative tasks like image generation, for example, or like music creation, that kind of thing.
Mm-hmm.
So yeah, hopefully that answers your question. I mean, in terms of image generation, I've not really experimented that much with Eliza in that aspect, but I know many people in the space have. But it's a good question. So I guess to just look at like the general structure of this project, it's basically the Eternum repo with Eliza running as a submodule inside it. Within the packages file, we've got the Eternum plugin. Within the Eternum plugin, we've got the actions, and here is the action that I'm going to talk about today, the generative action. One thing that I guess you don't really need to understand to use this, but it's helpful anyway, is like, how does the agent actually choose an action to do? Once you've kind of defined them in the character file or in the or you've hard coded them into the runtime, how does it actually know whether to select that action based on what message you send it? So for that, and this proof of concept just uses the Telegram client. So if we go to the so this file here that I've just opened is a package. It's the client Telegram package, and in this package there is a handle message function. So this is called anytime once you've connected up the client. One thing I didn't point out actually is in the character file you define the clients that you want to use here. So I've just disabled everything apart from Telegram. But yeah, if you wanted to tweet, you can just enable the Twitter client. But yeah, when it receives a message in Telegram, it will call this handle message. This does a bunch of stuff. It does a bunch of memory stuff, and it has like a should respond function, which is not really important for this proof of concept, but we can go into it if people have questions. But this is basically giving the agent some guidelines on whether it should actually respond, like whether if certain users are being if it's in like a group chat and people are not directly asking the agent a question, then it should probably ignore the message. If users within the group are being toxic towards the agent, using bad language and stuff like that, it will just ignore them. This kind of stuff. But I guess this is the important bit here. This is right before the message is sent to the LLM. It creates the context based on the message it's received, the current context that the agent holds about it's about the world, and this Telegram message handler template, which it's just here, is a prompt that is this is what's sent to the LLM. So it will action examples. So this stuff is pulled from. So this will exist within the agent's context. Also in the context is all of the actions that it has access to. You can see this kind of stuff here. Bio and law is injected into this prompt from the character file, so that the LLM can kind of enrich the responses in the style of your agent. any providers that are registered with the runtime, any actions that are registered. So in this case, it will be, the generate action, but also any actions that were included in that Bootstrap plugin that was also attached. Message directions like agent name, all this stuff is injected. So this is sent to the LLM along with a message that says something like "build me a farm," and then the LLM will respond, and based on the action examples that you've given, which I'll show you later, it will choose an action to take based on what it has available in its context. So sending a message "build a farm" the agent would decide to use the generate action in the Eternum plugin. Does that make sense?
Yeah, it does.
Cool. Okay, so now I'll move on to the generate, the actual action itself. So again, like plugins like these follow a set structure. You have to give it a name. The similes bit is so that when in what we've just talked about, where the client sends the message to the LLM, LLMs are non-deterministic and sometimes a bit unpredictable, so it might not give you back the exact action name. So you can define a bunch of similes which you want to use to be able to catch this action. When an action is registered with a runtime, validate will call, because it needs to make sure that the agent actually has access to all information it needs in order to use this action. So in this case, it's just validate. It calls this validate starknet config. So it just checks that you've defined a starknet address, your starknet private key, and an RPC URL in your M file. And for the purposes of this POC, I'll show you how to get those. So after that, if this is the first time that this action is being used by the agent, it won't actually have context of the Eternum game world, like what are the rules, what are the available queries and provider examples. So these really are the 4 key files that it needs in order to be able to play the game. And if you've been following what Loaf is doing with Daydreams, this is the sleeve. Basically, Daydreams refer to them as sleeves, and it's a file that the agent needs to be able to play a game. So in this case, you can think of this as like the Eternum sleeve, but this could quite easily be a Pirate Nation sleeve, or it could be a Loot Survivor sleeve. And well, the idea with Daydreams is that this is actually all you need to give to the agent to allow it to play any game. And the real kind of skill is then in prompt engineering to make sure your prompts are rock solid, so that the core framework doesn't need to change at all, and neither does the agent. The agent character file. This is all it needs.
Mm-hmm.
So I guess
is that all like hard coded context for the agent?
These 4 files.
Yeah.
I'll walk through each one of these now. Okay. So world guide, I guess, is the first one. So yeah, it's just a really long prompt which is fed into the context window. So basically, I won't read through all of it, but it basically gives it like, this is the contract it needs to call when it wants to build something. It will give you it provides some basic guidelines on building. So like, check what buildings you have using the Eternum building and locations. These are GraphQL queries. You need to check before trying to build something. You need to check building cost using the building ID. You need to make sure that you have enough resources. If you have enough resources, use Eternum create building. This is just something I added for the proof of concept, because for whatever reason the agent just kept trying to trade on the in-game market rather than just build something. And then it just outlines kind of like, how much does it cost to build each building, some basic descriptions of the buildings within the game, population requirements for each building, realm levels, and how much it costs to upgrade to the next realm. It lists all the resource IDs, and this stuff's just if you define this in this file, it just makes it easier to call the relevant GraphQL queries. Again, building descriptions, like some of the stuff in here is a little bit redundant. Like there's some duplication here and here, but the sleeve that is currently being built for Daydreams is stripped out a lot of the duplication, tried to make it a lot leaner. And then building types, some resource descriptions, etc. You get the idea. So this is kind of, and there's probably a lot more that could be added to this, but if you want this agent to actually be able to make a lot of moves in Eternum and actually play in a meaningful way rather than just building a farm, like this file is probably going to get quite big. It needs a lot of information about, a game as complex as Eternum. And the next one was world states. I don't think this one is as important because I'm going to try and run through a live demo on this call later after I've explained it. But even if you generate a random realm here, you're hard coding a realm ID here, and it doesn't seem to have an issue. So I don't think the LLM really uses this that much. The next one is available queries. So this is just telling, making sure the LLM has context around how to submit GraphQL queries. So it provides some common queries. The one that needs to always be used basically is to get the realm ID. And one of the most common issues I've come across, and I know other people trying to get this working have also come across, is the LLM either hallucinates when it does this and doesn't give you back the correct entity ID. It'll give you just back a random number, or it will retrieve the correct entity ID but not store it correctly in the context window as a variable, because obviously entity ID is used in a bunch of subsequent calls, like this one, to get your realm position, and to get realm resources and buildings. Entity ID is used again. So really, the pivotal one, the highest priority one to get right, is this one. You need to get that entity ID. So there's a bunch of examples, and then there's an introspection schema here, which, so rather than having to define an example for every single available query, you can give it this, which kind of instructs it how to take any of these and retrieve the information that they store, because obviously there's quite a lot. For the purposes of this POC, I don't think this is used very much because most of what we do is with these examples here. And then the final one, which is added, is the provider examples. So this is actually how to construct the StarkNet transactions. So once it's got all the data it needs from the GraphQL queries, the final kind of step in the chain is to submit a transaction to StarkNet. So this one here is like to create an order, which I'm going to skip over these because it's not really doing any market orders in the example. But create building, for example, this is what it will be calling at the end to build a farm or a fishing village. So it knows that it needs what parameters it needs to pass in, how to kind of pass the direction IDs, some key rules. So you can't build on 0, where your castle is. The distance from the castle is limited by realm level, etc. And then again, this stuff is redundant because it's kind of given in the world guide that I showed you first. But and then it just gives you like an example. So this is the contract call that it would make to actually create a building, and the call data that it would need to pass in. So that's how it sets up its initial state. And I think, a bulk of, the success of the agent being able to do stuff in the game depends on the quality of this stuff. The rest of it is, there's like some error checking stuff. The first step it takes once it's got all its context in place is to take the high level goal that you give it. So in the example I shared was build me a farm. So it will take that input And this is another prompt that it uses. Define steps. So this section here is taking that high level goal and breaking it down into smaller, achievable, kind of short and medium term goals. So if we look at define steps, which I think is, here. This is where it pulls it in from. So again, we're injecting dynamic state into this prompt before it's sent off to the LLM. So the high level goal, which is what the user sent to it in Telegram, world state is pulling from the world state that we saved in its context. Queries available is the GraphQL stuff. Basically the objective of this prompt is to return a precise sequence of steps to achieve the given goal. Each step must be actionable and directly contribute to the goal. Only work towards the goal you are being given. And kind of building this effectively, just it kind of hinges on being specific enough, putting enough constraints around what it's meant to do, but also trying to keep it concise. Because if these prompts get too long, then you end up using a lot of tokens for the LLM, and it ends up becoming really expensive. And I would say, like, just running this proof of concept, each time you run it, it might cost you like 50 cents to do like a single game move. So it's not cheap at this point. But as I think everyone expects inference costs to fall rapidly over the next year, over the in the immediate future, to be honest, especially with models like DeepSeek now coming to market. So that's less of a concern going forward. But yeah, right now, using Claude, for example, this can be quite expensive. So yeah, basically this prompt just gives it some rules about how to break down the steps, break down the high level goal into steps, and how it should output the format. So we want it to come back in JSON. Another issue that I came across when trying to get this proof of concept to work was the LLM would often give you stuff back that wasn't valid JSON, which was a pain. In Daydreams now, that has been there's like some formatting. Basically uses Zod to ensure that responses returned from the LLM adhere to predetermined schema, which removes a lot of that the errors that we were seeing in that area. But basically, yes, and some rules around error handling and how to prioritize stuff. And then once that prompt has been added to the context, this generate object actually sends this function sends all this information to the LLM to get some steps back. And this is just a part of the core Eliza framework. This is not specific to the Eternum plugin. And for that, it just uses Haiku in our instance, just a small model class, because we're not trying to do anything like particularly complex here. We're just trying to break a high-level goal down into smaller tasks. Then we do a little bit of formatting so that each of the steps all look the same. It just makes it easier to execute stuff going forward. And then we do some logging, and then after that, we add all the steps that have been generated to the current state of the agent, and then we sequentially try and execute each one of them using this while loop. So we have a step index, and each time we try to execute one of these steps, it will basically I think it's in generate step. Yeah, so here we've got this generate object again. Yeah, so generate step actually takes the individual step, sends it to the LLM, gets the response back. It updates the agent's context, and when it comes back, we will look at the response and basically try to like an action type. An action can have two types. It can be invoke, or it can be query. And this was in the step template prompt. if we just go back to here, at the bottom here, it says, each of the, you must return one of the following response formats. So we can either have an invoke type, which is when we want to actually do a Starknet transaction, or we can have a query type where we want to retrieve some data. And depending on what this action type is, the code will treat it differently. Also, something to point out, the LLM will return this next step, which is the step it recommends you take after executing this one. So if it's object type of invoke, we'll take the data, we will pass it to JSON and use it to call Eternum in the call Eternum function, where we will compile the call data. We will get the Starknet account, which will be defined using the public and private key that we put in the M file. And then, we'll execute the call and wait for the transaction to complete. If it is a query type, we'll take the content, the data from the content field, we'll pass it again, we'll send it to the fetch data function, which creates a GraphQL query to retrieve the data, which is then brought back and stored in the agent's context. And then if there is a next step defined in the step, we will increment the step index, and then we will add all of the recent execution to the agent's context, and then we will basically go around the iteration again and execute the next step. This happens until all of the steps are complete, at which point the agent will stop executing and wait for further input.
Okay.
I think that about covers it.
Yeah, I mean, this is what a really good overview. Thank you. And the goal of these agents really is to, in a scenario where the human, right, so where the real player is idle, it would be most likely used once that player is idle, and you want to keep your farm going, and you want to keep your world, you want to keep tapping into Eternum. And so, is there a way for the player to actually, maybe in the character file, but to give more of a personality to the individual agent? So assuming that, I go, I play Eternum this morning, and then I have to go have lunch and then have a coffee with a friend, but I want to keep my world growing, right? And I activate my agent. Is there a way to kind of give a personality to this agent to do certain tasks that I want it particularly to do, or will it, or is there also a way that it kind of generalizes the activity within Eternum, so it doesn't do specific acts per se, but it just keeps the world going?
So I think there was potentially two parts to that question. First was like the personality. So in the character file, you can define like how you want your agent to communicate. What is the agent's law? So here, this is, the original character was based on Gandalf the White. So there's just like some stuff in his bio and law, fairly similar, to be honest, like guided the fellowship with wisdom and courage. He was served the Valar in the Undying Lands. This is all part of his law. So this stuff, recall I was showing you the prompt that was used when a message came into Telegram. This stuff that I'm showing you on screen now is injected into that prompt, so that any response it gets back, it knows to respond in this kind of style. Knowledge again gets injected. Message examples. So this is how you want your agent to respond to messages it receives. So you can have any number of examples in here, and I believe the way Eliza works is that it doesn't just take all of these. It selects a few of them at random and uses those to feed the LLM to enrich the response. So like the more you put in here, the more dynamic and varied that response is going to be, because it's got just more options to pick from. Post examples, this is kind of more for Twitter. Just some example things about what it might want to say, what it might say on Twitter, topics that it likes to talk about. So when I was testing this with Twitter, you could definitely see that its tweets were themed around these the things in this array here. Style has 3 parts. So you have like a high-level style, which applies to all of the agent's communications. And again, you can put as much or as little as you want in here. And then you have chat and post. So chat is more, when you're interacting with it in DMs. Post is obviously public stuff that it communicates. So yeah, that's how you define the personality of the agent. There may be a way to, like, if you. So the second part of your question, I think, was like, how do you, if you want to just leave the agent to do its thing in the game, how do you ensure it acts in a certain way? Like, is it a good agent or is it a bad agent? Is it going to raid bases and betray people, or is it going to act collaboratively? Is that what you meant by that question?
Yeah.
So there may be a way to put that in here, but right now the way that the generative action behaves, I don't think there is a way to do that right now, but it's certainly something that could be built. But I think it all depends on the high level action you give it. So you may be able to, instead of just saying build me a farm, because that process takes like 2 minutes, if that, you could say, I want you to find the nearest base to your castle and take it over. Do not ally with anyone, only attack, or something like that. And that could be a much more long-running goal because, due to the amount of moves, the limitation on moves that you can do within a day, and resource constraints, that particular goal might take 3 or 4 days to finish executing. So depending on the goal you give it, like, that'll determine the amount of interaction you need to have. You might just want, and if you just want to give it like a bunch of small term goals, for it to complete, like, you're kind of taking the part of breaking that high level goal down yourself, or you can give it a high level goal and allow the LLM to break it down. So yeah, if you want to be much more involved, you can just keep giving it short term goals, which take a few minutes, while you walk away from the game, if that makes sense.
Okay. And if I have one big goal and I break it down as you've shown, what if I have suddenly another goal? Does it break the current process, or does it wait and finish the first goal or the first mission and then move on to my next mission?
So right now, I don't think the functionality exists for it to run multiple goals in parallel. You would have to either cancel the current goal, whether it's that it's pursuing, or you would have to, you would have to wait until the first one had completed. That's just with this proof of concept. Like, Daydreams is moving very fast, and if people find any of this interesting, I would encourage people to go in the Daydreams Discord, download the repo, play around with it, because the functionality that it's not just love. Now there's a bunch of community contributors all working on different bits of it. It allows these agents to act in a much more reliable way, I would say. Like I said, like the constraints around type that the LLM can respond in just makes the whole process much more reliable. There's a specific class for managing goals now. They have the goal manager class, which is solely responsible for breaking down and organizing goals properly and setting up dependencies between goals. It's a good question about, like, kind of parallelism of goals. I guess there's nothing stopping you from spinning up 2 agents at the same time and giving them both separate goals. That's doable within the Eliza framework and within Daydreams. So yeah.
Okay. And yeah, I'd love to hop into a demo next, but just before that, I had just one last question also regarding Daydreams. So you've mentioned that you're moving from Eliza to Daydreams, and for obvious reasons, also because you're working on a fully on-chain game. What's the difference that you're looking for that is in Daydreams that you cannot find in Eliza?
So Eliza's great, but the one thing I would say is that just due to the fact that it's so broad, it can be used for anything. Like there is the core framework, which can be extended with a bunch of plugins. And by the way, this is something that they're addressing in V2, which is dropping in the next month or two. But just by the fact that it's kind of like a general purpose and really extensible framework, it's invited a lot of contributors, which is a great thing. But one, it makes version management tricky because so much code's being pushed all the time. So until they reach a stable version, if you don't pull the code down for like a week, you're already like 150 commits behind or something like that. And Daydreams, although it's not solely pursuing on-chain games, it's using on-chain games as like a beachhead, given the high complexity and relatively low stakes of on-chain games. The core framework is really designed to operate effectively within that environment, and once that functionality is hardened, I mean, it's still not trivial, but it's relatively trivial to kind of take that chain of thought and hierarchical task organization to other areas of crypto, like DeFi, for example, where the stakes are higher. But the initial focus on-chain games is just a great fit for what I want to do. And obviously, I've known Lo for a long time, and I have a ton of respect for his developer chops and want to support him wherever I can. So also helping out, contributing to the framework. And it's just really exciting to be at the start of something and being able to watch it grow and help it grow as well. So
Amazing.
But yeah, happy to jump into a live demo, which may or may not work well. we shall see. But let me just open up the Eternum client. Okay. So I'm just going to take my. All right. First of all, I'll show you how to get the. So this is one I've already kind of initialized. So I should have some resources already. Let me just check. No, I haven't. I need to claim. So yeah, just this proof of concept is very hacky, but you could imagine, any agent coming into this world at first you could automate that claim process, but right now, like, it needs some resources to be able to do anything in the game. So I've just manually claimed them, and to get the burner wallet address that we're going to need, you need to go into applications. Where is it? Oh, hang on. Yes, there we go. So yeah, you've got your Burner's Katana wallet here. So this is what you will need in your M file. You'll need to get this is your Starknet address and the private key. You just need to put that in the M file. I'm just going to drag this off screen so I can check that I have the most recent M file updated. Yep. So yeah, this is an example M file, but yeah, you would just need to. Where are we? Starknet. Yeah, so this is the RPC URL you will need. It's just the local host. And then, yeah, you would just put the address and private key in here. And then if we... Okay, I'm just going to start the agent with pnpn start. Fingers crossed this worked. It worked before the call, but the perils of live demos we shall see. Okay, the agent started up correctly. You can see that the Telegram client has successfully started for character the White Wizard. So if we go to my Telegram. Okay, I know that's probably a bit small, but let me just see. I'm going to use this message again. So I'm just tagging it in this chat. And I'm saying, build me a fishing village. So we can see that the LLM gets that straight away. We can see that it's using the small Anthropic model provider to break down the goal into subsequent tasks. It's following the rules that we've given it in the prompts that we discussed earlier. Okay, so it's moved quite fast there, but you can see it's responded to the client saying these are the steps that it wants to execute. It wants to query the realm position, then it wants to query resources. It wants to identify a good position for the fishing village. It wants to create the fish, and then it wants to build it. You can see it's kind of hallucinated here a little bit. It's wanting to create fisherman huts, which don't exist. So that's an issue with the prompt. But yeah, you can see there it did a StarConnect transaction in the. Yeah, it's I think we've maybe lost that. Yeah, we filled the terminal window there. But let's have a look. Yes, it's built a fishing village. So what you would want it to do now, and it's just built another one there. Look, what you would want it to do now is it will probably. So in the example I shared on Twitter, I initially asked it to build a farm. It started off building 2 farms, then realized it actually didn't have enough resources to build a 3rd farm. Then, because we've given it the context it needs, it knew that it needed more fish to be able to build a farm, and it knew that it needs to build a fishing village to get more fish. So in the initial example I shared, yeah, it built 2 farms and then decided to build a fishing village in order to build more farms. But right now, like it's the proof of concept as it exists here is not going to be advanced enough to give it a go, like win Eternum. Oh, like you just built a farm. That's pretty cool. Because it's obviously realized that it's not being able to build a 3rd fishing village. But yeah, so the more advanced that this gets, like the more longer term goals you're going to be able to give it, and it's really just like as someone that comes from like a traditional software development background, working with something like this is you have to change the way you think about it, because LLMs are non-deterministic. It's very difficult to write tests for stuff like that because they by the nature of being non-deterministic, they can give you different responses each time, and it really ends up boiling down to being good at prompt engineering at this point. Once the core framework functionality is built out, you just need to know how to prompt these things properly and handle errors effectively. And there's stuff in here where inside the prompt which instructs it to go back and try it again, like read the error that comes back from the LLM, and then try again, taking into account the error to try and fix itself. And all of this stuff depends on being able to write effective prompts, which is something I'm still learning, but it's a fun area to dive into, I must say.
No, but this is all super impressive. And have you already done a POC with Daydreams then?
Not yet. I've been focusing on, so I've been playing around with it, but like it's been used. So I had been trying to replicate this with Daydreams, and in doing so, it's highlighted stuff that needs to be built in Daydreams and stuff that needs to be tweaked. Ways in which agent context can be managed more effectively rather than holding everything in the context window, for example, which can get really big really quick with a game like this. Some stuff is better to store in the vector database, and just retrieving things that are relevant to the current goal that it's trying to execute. So stuff like using memory more effectively. And Daydreams has only been in development for, I forget now, like a month or something. So by trying to get this proof of concept working through Daydreams, it's highlighted a lot of stuff that needs to be built and changed. But yeah, it's certainly close, and I'm hoping to replicate this with Daydreams very soon, but also replicate it with other games as well. So watch this space. I think, and there's lots of other people. There's a guy that I chat to often who's building one for Kamigotchi. Someone's building one for, when I say building one, I mean a sleeve, which is one of these prompts that we talked about. Building one for Kamigotchi, one for Loot Survivor. There's a bunch of other games, and I have plans for games that I want to build them for as well. So I say it's an ambitious goal, but it's definitely exciting and a worthy thing to spend time on in the space.
Amazing. And this is moving really, really fast. Where do you see it in 6 months? And especially with frameworks like Eliza and with Daydreams and integrations within Eternum, like how do you see it evolving?
I mean, I put out a piece for Bitcraft recently, which I shared on my timeline, and it's on the Bitcraft website. So people, I go into a lot of detail in that article, but I guess that a couple of things that I'm excited to see is there's the whole autonomous player thing, which is what we'd be discussing today, has the potential to solve the cold start problem that a lot of games have, not just on-chain games, like indie games in general, but we're focusing on on-chain games at the moment because they're kind of like the perfect playground for these agents with the whole state and being on-chain. They effectively have an open API that can be called permissionlessly. So it's almost like they were purpose built for these agents. And from day one, people can, if agents are incorporated into these games, and these agents if they're programmed to behave in ways that are conducive to good gameplay, that depends on game design as well. Like there will be a lot of games where these agents come in and completely ruin it. But I think going forward, like a lot of game designers probably need to think about how agents are going to be incorporated into the game so that it's net positive for human players. You can walk into a dynamic world from day one, and it's not just a ghost town. There's people to interact with, people to interact with. You can hire agents to do the grind for you if you want, or if you enjoy the grind, you're more than welcome to do it yourself as well. But like a lot of people don't have time and just want to engage in like the more exciting parts of the game, like combat, questing, etc. I also think another really interesting area to explore is having NPCs that can also act as KOLs for games. So, you meet like a Blobbert, for example, inside of Eternum. He might have his own castle, or he might be, a bandit. It might just be a bandit camp or something like that. But you can chat with him. His personality will be in the character file, so he will respond to you in the Eternum chat in character. But also like Blobbert can then have depending on how you set up the rooms in the memory, and by room I mean just kind of like the logical separation of memories. You can program it in a way that like it's all isolated. So like if a user interacts with it in the game, but this agent is also on Twitter, then it won't have any kind of context of those two interactions and how they link. But like if the game and the Twitter clients share the same room, the same logical component, kind of boundaries inside the vector DB, then this agent can talk to the player on Twitter and remember what happened in the game, and vice versa. So this is like interesting. I think it's an interesting user acquisition angle, and also like engaging players like wherever they are. Because Blobbert could be chatting to people on Twitter and then say, "Oh, like, why don't you come and play Eternum? I'll guide you through the first. I'll teach you the ropes. I'll guide you through the starter quests or something like that." And you can just share a link in Twitter. The person goes to Eternum. They've got the cartridge controller already prepped to go. They don't need any tokens or anything. They can just start playing, and as soon as they enter the game, Blobbert's there with them, guiding them through the starter missions. I think this kind of stuff is really interesting.
Nice. And what do you think is missing in the space in terms of additional infrastructure or applications or agent marketplaces? So things that need to be built that aren't the agentic frameworks, like the agent frameworks themselves, but things that we need to build as a community to onboard those new devs and those Web 2 devs and just make it easier to start working start working with agents in games.
So I think in terms of onboarding developers into the ecosystem, I think the Shaw at AI16Z has done a good job with the agent dev school. It's having good tools like Create Eliza app, I think it's called. It's like Create React app where you can bootstrap a project like really easily with a single command. Stuff like that. And also just, I would say, like, I don't think there's no shortage of agent frameworks already in the space. Like, we're seeing new ones springing up every day. I think, and in my opinion, like, unless one of these new ones is really 10x better than the existing incumbents, and by incumbents I mean Eliza and Virtuals, I think people will probably, developers will likely go to what's Lindy, i.e. Eliza. I believe that what Daydreams is building is 10x better than what's come before, just because the code is so it's just the framework is very lean, and the way it handles memory with vector embeddings and stuff like that, it's very good and well designed. So like that's where I'm placing my time. That's where I want to spend my time. But there's a ton of new platforms coming out daily which increase competition and make it harder for developers to choose where to launch their agents. And I just think people will naturally gravitate towards the ones that have the most integrations, the best open source communities, and the best developer support. Basically, I think it all boils down to developer support and onboarding people at this point. One thing that I know we've been going for an hour already, but one final thing to say is when this gets really interesting is when these autonomous players and agents within games can swarm and share knowledge between each other. So if one agent is successfully able to build a farm, there's no need for subsequent agents to then continuously call the LLM to try and get the same response. The steps and the subsequent StarConnect transaction data can just be stored in memory and shared through the swarm, kind of like a caching system. So, some agents that want to be more competitive may choose not to share this stuff, but I think a lot of agents probably will share this stuff in the swarm. So, like the swarm over time, the swarm intelligence kind of goes up, and the token requirements for the LLM goes down. So I think it'll become much more economical to run these as well.
Okay. Nice. Yeah, we're running a bit over 1 hour, so I think we're going to close the workshop for today. It was really, really interesting, and especially to dive deep into how Eliza works, but also what the plans are with Daydreams. That's all super interesting. Where can people find you if they want to talk to you, if they have questions regarding Daydreams or Eliza? Where can they shoot you a question?
Yeah, cool. The best two places I would say would be the hackathon Telegram. Just tag me in there if you have any questions about what we discussed today, and I'll try my best to answer any of them. Or the Daydreams Discord. I Twitter DMs are not a good way to contact me anymore, so just stick to those two channels, I would say.
Amazing.
Thank you for having me.
No, of course, Technoir, of course. Amazing. All right, then we're going to close off the stream. I hope it was helpful for any curious minds who want to look into Eliza and also Eternum. And I wish you all a good rest of your day. See you. Bye-bye. Thank you.